All right, welcome everyone. This is our first session of Coding Saturday. And for this first day, we're going to just basically talk about what the cloud has been doing for the past, 2 months. And walk through some of the stuff we did, especially in my team, which we've been working on the small size league. And we have the simulator called grSim that we found, which is by Team Parasonics and not Parasonic, Parasyn Robotics. And I'll walk through the process in which we develop our version of this code. And hopefully it'll help you in a bit. We are developing your code for the Sim 2D. That's the purpose of this presentation. So, to get started, this topics we'll cover today is first I will see you the current version of code we have in action, which is a video. Then we're going to talk about a bit of the stuff we used to develop this code, which is sockets, portable, simple inheritance stuff. And then I'll actually show you the code and put it all together by means of I'll edit it in front of you and to get the results from the video we'll show in the beginning. And on the bottom line is the GitHub account where the repository where we store the current version of this code right now. So I'll show you. So this is the code in action. So now you see we have obstacle avoidance. That's the first thing we did when we tried to do. Because for the qualification video, we needed to do a number of things. First is one-on-one, which is you have right now the player versus goalie. And we found the problem that the robots tend to run over the ball a lot. So we had to do obstacle avoidance. So we just made it avoid robots and the ball in general. So we would walk around and actually go to the position in order to achieve the shot. So this is one of the first things we did. It's a goalie versus player. And now this will have a cooperative gameplay where one attacker will stay in the middle, and whoever's closer to the enemy end will become the attacker. It will stay in the middle to wait for a pass. One other robot will go retrieve the ball and pass it to the attacker for the shot. However, if the attacker is closer to the goal himself, he just shoot himself. And then since we have the basic 1v1 AI working, we've just figured out we're going to put goalie on both sides and attacker on both sides. And we have this a simple 2v2 game going on. The goalie on the left side isn't implemented perfectly yet. So we can see we have a simple 2v2 game. And with the co-op setup, we actually have the 3v3, for example, set up as well. It's simply a co-op play on both teams. We'll get to that in just a minute. This is a 3-3 gameplay where there's a co-op. There should be a goal here at the beginning. There's a pass. Yeah, that's that. So that's basically that. The link on the bottom is where this video is hosted on YouTube, so you can go check that out if you want to. Both the slides in this presentation and also the code that I'll be talking about will be online together with this video as well. So you have that for later. One of the first things we did was sockets. You'll use this a lot when you're doing soccer simulations. Basically, this is a communication protocol between the simulator and your clients, which are the teams. Every iteration, the server will send out information about the field to all the clients that are connected. And then the clients are supposed to interpret this information and then send back commands in which to move the robot in the field for soccer simulation. For our purposes, we downloaded the simulator from this other team. It was open source. And we hacked it to put our own UDP socket inside, as a UDP client inside, to send the package to a specific port that we chose. And then we have our coach, which is the program that actually listens for this information and gives a command to move the robots that's outside. So we basically, it's not supposed to be done this way because the grSim actually has a default port which sends the package to, but to achieve the full handshake for the sockets, we just hacked it for a momentary solution, but that will be fixed. So basically, where sockets are is that they are a placeholder for you to send bytes of data, and this can be any arbitrary data, as long as you have the correct protocol on both ends to receive and interpret it. So I should probably show the code that we have for this. So this is our code, the client code, and this is actually a UTF server that's constantly listening on port 30015 for incoming information about a field, which is wrapping Google protobuf, which I'll talk about later. So this is basically out of the box a UDP sample code that we took and modified for our own purposes. So it basically gets a string, which is the message received at this port, and we parse it into this packet class, which I'll talk about. It's the information of the field. All right. So Google protobuf. What is Google protobuf? This is a protocol for basically compressing data into different formats. For our purposes, we use a string to achieve the data communication. So what you do is that, for example, you will have a message you want to send, and you write a proto file for it. This is the format defined by protobuf. And for example, this one has a SSL detection robot class. Basically, it says where this robot is. They can have many of these, and basically the soccer ball you play. And then you run this through a compiler. The protobuf currently has compilers for C, C++, and Java, and it'll generate some code. For example, like this. This is a C++ code. It will generate this huge class file. You do not need to edit it in any fashion. It comes out with Google Dark Magic. And you just include this in your file, and then link it properly in your makefile. And then you gain access to a variety of functions. For example, the parse from string from a string message. And on the other end, there will be a serialized to string function that basically you put this class. For example, packet is a SSL wrapper packet was one of the message formats defined here. And then you can essentially send classes through sockets, and that basically helps the data communication a lot. And the thing about protobuf is fast efficient and high compression ratio. Also, you don't have to send a bajillion-sized string to pass all the information. It's much more compact this way.